Hi guys, and welcome back. Mr. G here. And just a recap. In the previous video, we had a triangle, which was a right angle triangle, like the one I have here. And we established that if we want the length of this side here, through the theorem of Pythagoras, if I may remind you, this is hj, okay? So if I would say hj squared, then this will be hi squared plus ij squared, right? And then we established that actually at the end, it all comes down to saying, well, the y coordinate at h minus the y coordinate at j all squared plus the x coordinate at h minus the x coordinate at j all squared. And we realized it does not really matter how we put it up because they are all squared, will always be positive. So I can rewrite this thing also now as a xh minus xj all squared plus yh minus yj all squared, because when we read coordinates, we start reading off of the x coordinate. So really, that's a matter of convention and convenience. So because that is hj squared, if I want hj now, I'm going to have to take what? Square roots on both sides. So we then ended up with something like this. Hj minus xj all squared plus yh minus yj all squared, right? So we established in principle, in general, between any 2 points, in this case, any 2 points j, point h and j, if I want their distance, I can simply say x at h subtract x at j, square the result, add to what? Now yh minus yj, and of course, you square the results as well. So, of course, in that case, we had ABC, and then you've got to learn to adapt now to the different coordinates that you will be given. So let's look at this one. If I want the distance AB, okay, without having to use a ruler to measure or without having to construct a right angle triangle here, and then using the theorem of Pythagoras, we can just use this general rule that we have. I know that, excuse me, AB will be the square root of x at A minus x at B all squared plus y at A minus y at B, and that's all squared. And then I just substitute. X at A is minus 7, here it is, okay? And then x at B rather is minus 2, so now this is time when we become more cautious, okay? Notice how I put that. And then y at A is 11, y at B is 10, and I got to square that. So you notice now I have minus 7 plus 2, not minus 7 minus 2, right? Substitution is very important, guys. And 11 minus 10 is just 1. I'm going to square that. So finally, what is the difference here is minus 5. So, okay, maybe let me just write it because we are starting, right? You will see I'm going to start omitting some steps as we go through these videos from one step to another. And I'll be under the impression that you now know the drill, okay? So now this will be 25 plus 1, and that's all under square root, which is 26. So square root 26 is the answer. Okay. If you want to write this as decimal, of course, that would be per instruction that is given in the exam or in the test. If they say leave your answer in set form, then this is what they mean. Leave it as a square root. If they say round off to 2 decimal place, do so. Okay. Sometimes a paper will just say in the instruction, in the list of instructions, they'll say where, unless specified, round off your answer to 2 decimal places. So that was like some of the instructions that you'll be getting. So guys, I want you to try this one here. Try find the length CD. Okay, what is CD equals to? Okay, Even if you write DC, it's still fine. As I said, it's the same thing. Okay, saying DC is the same thing as saying CD. Okay, because the length will be the same, right? So try this one and see if you can do that. All right, I'm going to leave it up to you. The last thing that I want to talk about here is this triangle in the middle here. Okay, I'm going to clear up all the or everything that I've written. So I want us to focus on this triangle here in the middle and uh, discover one of the useful things that we can do with the distance formula. So we are supposed to prove that this triangle is isosceles, okay? Now, how do you prove that a triangle is isosceles? Two things. You know that a triangle is isosceles if angles on the opposite sides are equal, okay? Or the base angles are equal. So that is, if the apex is given, you know that is the top of the triangle. Another way to prove that is to just show that the two sides are equal. So in this case, we don't have any information that is provided regarding the angles of this triangle. The only thing that we have is the coordinates of each point. So for us to prove this, we just need to go straight into the distance formula, okay? So I'm going to go ahead here at this point. We are literally going to find the distance for each side so that we can find out which of these three sides, okay, which two are equal, okay? So without any further ado, so let me maybe write here RTP means required to prove, okay? We are required to prove that the triangle EFG is isosceles, okay? And I'll just stop there. The lazy mathematician does not enjoy writing a lot of stuff except the symbols, okay? That represent what he or she says, right? So let us start number one with side EG, okay? If I want the length of EG, distance formula, x at E minus x at G, I must square that, plus y at E minus y at G, all squared, okay? And I still keep my square root. And this is one of the reasons I really prefer having EG squared here, because then I don't get to write a lot, okay? So in the next one, I'll do EG squared and then put the square root at the end, all right? So I'm going to now substitute, right? X at E is -2. I subtract x at G, which is 2, all squared, plus what is y at E? 6. What is y at G? 3, all squared, okay? So I'm going to put this again. Guys, this is not 0. You're saying -2 minus 2, that's -4. Really, it is not bad to put this in your calculator. You can do that. In fact, you can just put this whole thing in your calculator. You've now got the Casio FX82Z8 Plus, I think, which is a very clever calculator. So you can just put that at the end. But for accuracy, so to get you used to the routine, it is of course a nice thing to do that. So we see this is square root of 25, which is 5. And as I said, I'm not going to write plus minus because we know distance is positive. All right. Now I'm going to go ahead here and look for the distance EF. Okay. As I said, now I prefer to do this because I don't want to waste my time writing lots of square roots. So I'm going to do that. I'm going to take it right straight from the Pythagoras. You can do the same. It shouldn't hurt. Now, of course, I substitute again. This is -2. X at F is -5. All squared plus y at E is 6. We know this one. And then y at F is 7. I have to square that. This is -7 squared plus -1 squared, which means we have here 49 plus 1, which is 50. So EF squared is 50. So if I want EF, I must take square roots both sides, and the square root of 50 is 2 square root 5. What's happening here is you should think of 50 as 25 times 2, okay? So you should think of 50 as 25 times 2, and then you take the square root of this out. So basically you are having 25 square root of 25 times square root of 2, because we know from sets and exponents that square root of AB is the same as square root of A times square root of B. And so this thing here, that's why it will be 5 square root of 2. So actually, that's what I meant to write here. Okay, so that's okay. In any case, that takes care of it. Of course, you would have gotten this right away if you punched it in your calculator. But at this point in grade 10, the teacher will require you to put down all the steps, okay? So I think there might be marks for substitution and some simplifying and stuff like that. So of course, when you get up to grade 11 and all that, we don't really now care much about the steps, because the assumption is you are well trained and you know how to do this. Now, guys, that's 5 root 2. And if you are going to find the distance FG, we still go around with the same drill. So I'm not going to put down the formula here. I'm just going to go right away and say 5 minus 2. You should put the formula, okay? And I'm going to say 7 minus 3. And I think we now know what we are expecting here. This should be 3 squared. That should be 4 squared. And this is, of course, 9 plus 16. And then this is 25. But this is FG squared and not FG. So if I'm taking that, I get 5. So we realize that actually FG is EG. So this side here is equivalent to that side. And because of that, we can conclude that the triangle is isosceles. And so that completes the proof, okay? That's all you needed to prove. And another case could be proof that this is an equilateral triangle, prove that another one, they could give you a square and say prove that this is a square. You know, in a square all sides are equal. Or they could say prove that this is a rectangle or it's a parallelogram. You just have to take one of the properties. In the case of isosceles, there are two properties. We know those angles would also be equal, right? But we just took this one because we had enough information to use it. Okay, so even in the case of square, you actually could prove that lines are perpendicular. You will see this one will become handy when we have addressed the issue of the gradient. Okay, guys, let me not take much of your time and leave it here. In the next video, we will move on to the next section of discussing the midpoints of lines. I hope you've enjoyed. Take care.